Hello everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. That's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody. Welcome to this Devember Day 9 dev stream where we're going to flail around wildly like wacky inflatable arm tube waving guy. You know, that thing you see outside of car dealerships. The goal for tonight is fairly, let's say, laid back and easy. I wonder why I didn't do that last night while I was doing stuff, but we're also in the vicinity modifying code here, and the idea is to make our C-sharp code read binary messages. And we're going to try to start with getting it to receive binary messages and then display them on the screen, and then follow up with trying to transmit them away, which should hopefully be not that big of a deal. Now, this is going to be still very simple echo servery. We're not going to have a lot of server logic in here like we do on the client code. The idea is just to make it do stuff. And probably going to be a little low key tonight because the waking up really early and staying up really late is starting to get to me. I am drinking late night coffee, not a mocha this time. It's something else, but in a bid to try to keep myself wakeful in some fashion. And I'm one of those people that caffeine doesn't seem to have that kind of effect on me. In college, I would spend, the entire day drinking coffee and then have a very vigorous nap and still be ready to work on going to bed later on. But nevertheless, we can nothing to it but to do it. So let's go ahead and jump in. Now, one thing that I was sort of curious about here is we do have this build client class that contains all of this nice state information. Now we're creating them when a socket is accepted. We're creating a new build client and providing it the socket there. Now I'm assuming it's not passing it as a parameter because reasons. Now here's the other thing, and I am of course very light in the ways of the deep, dark recesses of all of the fancy things you can do with C# code, but this is creating a new async callback on that read callback thing. Is it necessary for this to create a new one every time? Are these not reusable? This is one of those things where, because this is example code and it's meant to examine one particular thing, which is the asynchronous nature of this, the code is probably simplified in a way to such that, or maybe I should say it's simplified in a way that it's creating a new one of these every time, um, just to make it easier, but you don't have to do that, and maybe you shouldn't do that. Or alternatively, maybe you absolutely do. It's really hard to tell. But I kind of like the idea of this build client actually having nice state in here. And I thought we might start by actually boosting the code from the asynchronous socket listener class here out into here just to see what will happen. Now, just to verify, that does still build, and I can run it. Now, I was running that here, wasn't I? Like so. And now if I, whoops, that's not the console I wanted. This is the console I wanted. If I telnet to that host and type some text followed by the EOF, we can see it's doing its thing and closing the connection. So it seems to be doing what one might like, and this is the sort of thing that one might do piecemeal. So if that's the case, maybe we might say public build client with socket and this dot socket equals socket, and then in the place where, now that's the definition, huh? If we search for new build client, we could pass in handler instead of doing that, right? Which of course compiles, and I can't envision a world in which that doesn't actually work. That's not entirely true. I'm always sort of surprised when some things tend to work. So that's still good. So that's nice. Now that's one little thing there. Now, we need to have a couple of things here. We need to have read callback. Now, if I was, and we'll try to do this stateful like, what happens if I cut this entirely and put it up here? And further, I'm going to assume that this doesn't need to be static per se. It probably was maybe just static so that the sample code didn't have to create an instance of a class in order to do something. That is a guess. So we maybe that's the case, maybe not, because this does seem to be getting a result there. Theoretically, if it got itself, it might know. No, we're going to do it this way. We're just going to see what this does. Now, client, of course, is coming out of there, and otherwise, could we say client.read callback in that one? And the other place where read callback is used. This is just a sample. I'm not sure. Okay, so that's that one. There's still one more. That's this one. Client.read callback. So if we were to just examine the changes that are in that file, we added a constructor. We created a read callback up here, which I think is more or less exactly the same thing, except that where it calls begin receive, oh, it doesn't have a send, so it might not compile. We could comment that line out because it doesn't really matter to us so much as knowing that we read the data. And we don't have to pass that in, and that whole thing is gone, and we pass client dot. So let's actually try to build that and see what happens. It's an exploration kind of night. Yeah, send doesn't exist in the current context. That's okay. We're going to just comment that out. So the theory is that if I run that, when I connect, I should be able to type stuff and it reads bytes. And when I do that, it has some stuff, other stuff, and end of file, but it doesn't actually echo it back to us or do anything. So if I quit, it doesn't seem to notice that this is the case. Now, did I not? That's an interesting. Whoops, that's not the build results. That isn't. Oh, that's all right. It was this thing. It's still reading, but it doesn't know that the callback has ended, and it doesn't say client close connection, but it also doesn't say that it read any bytes. So that's kind of telling. But let's go ahead and proceed with the whole thing. So we added read callback there. Now we might guess also need, if we want to get this sort of working, to pull send and send callback out of here as well. Like so, and put them up here. Now if this works out, we can boost it and put it into its own class, which is going to be nicer to look at anyway, right? Okay, so let's see what we have here. If you called send, okay, let's say it's private for now. Well, no, let's say it's, nah, we'll keep it as private until we know better. Now we don't need to do this, I don't think, because we can just invoke it on the thing we care about. So we don't have to say client.send or that, or that, or that, or that, or that. Maybe those would all be this. Just spitballing how this might look. And if we did that, we could actually say client.send and get rid of that. So you're telling the client to send this data. It privately uses this object's send bundle, this being the one that was invoked on, sets the send bytes, calls that with send callback. Now this, was that one still private? We made that one public, so maybe we make that private as well. Or was it just always private? Was there a weird mix here? But it's not static. And it still has to do that. And what change did I make for this? Now it's being called, it gets a client out of the thing, it says it's sent, shuts down, closes connection, begins send to the new async callback send callback. I guess I probably need to put client dot on that one and client dot on that one. Does it still compile? No. So what's wrong? Line 247. Oops. Client read callback. Okay, so that actually does need to be public. Which was this one? And I suppose the other one should theoretically be maybe the same. No, that one's happening inside. Client doesn't exist in the current context. 105. Oh, that should be this dot send callback. To be honest, I'm not 100% sure that this is actually safe, but in a world of uncertainty, why not try it out? So on the face of it, that still seems to work. And that still seemed to work. Some stuff, other stuff, quit. What did I do that required me to have to close it without typing? I typed hello twice? No, I did not. Huh. I don't know why that might be the case, but nevertheless. I think it's actually not too shabby as a change, perhaps, and we might want to actually clarify some of this a little bit more before we zoop it out. Empty constructor, start listening. We need to, so the accept callback needs to be able to kick off a read in the client. Now, client read buffer 0, client read buffer size. What did we do up here when we did this? Begin receive, client read buffer 0, client read buffer size. That is in the read callback. So that is, I would imagine, exactly the same as what we did down here. I'm going to copy this and bring it up here to compare it and contrast it. As a matter of fact, what I can do is compare to clipboard. Oh, whoops, no. Compare selection to clipboard. No, that still just wants to put the whole file over there, and then there's that one bit right there. Now, to be honest, it's been a little bit since I used this because I've been using merge quite a bit. So maybe we'll just go ahead and do one of those. Now it's handler instead. It's still client read buffer 0, read buffer size. No flags, new callback for client read callback and a client. So those two things are in fact identical. So what if there was a public begin reading method that does this? So it tells you to begin receiving on this read buffer for that read buffer size with the new callback of this read callback and this, let's say. And if that is the case, we should be able to say client begin reading and remove that. We can also do that. Well, actually, whoops, I meant to do that. That can be begin reading, and the other one here in the asynchronous callback, the accept callback can be client.begin reading, like so, and this doesn't have to be here either. And method must have a return to, oh, whoops. Spend too much time using typeless languages and your whole head just goes to pot. So if I try to run it now, does it still work? That seems to be happy. That seems to be happy. 1, 2, 3, 4, 5 carriage return line feed. All right, so that is again still doing what one might want it to do. And if that's the case, we can call begin send here because you're just saying send this data, and we're going to actually maybe make that public. And the send callback is going to call begin send again. So we don't want to, I guess we could make a begin receive or begin send just like we did, begin reading. We could do begin sending on some bytes, right? Which just does this. Because this one is actually different from this one, but in a way that doesn't matter. The send buffer and the send buffer. Byte sent, which we set to 0, so that's still the same. Here we're explicitly setting it to 0. Here we're saying byte sent after we had set it to 0. Buffer length is still, well, buffer length minus byte sent is still going to be buffer length if byte sent is none. So let's actually copy this one and say public void begin sending. And it requires you to set up the appropriate data. Now, we probably don't need this either, I would imagine. Oh, we do need it for that one, but we don't need it for those ones. Well, let's just leave it there for a second. We'll take this one out. I just want to get this clear in my head. That are all thises. Oh, and 1. And does it still compile? Yes, it does. So begin sending is going to assume that you set up send buffer and byte sent and know how to do something. So if that is the case, then here we can say begin sending instead of that. And again, remember, this .send buffer is the same as this .send buffer. Here we're passing bytes sent as an offset, and here we're passing 0, but we set byte sent to 0. Here we're passing buffer length. Here we're passing buffer length minus byte sent. Buffer length is something, byte sent is 0, so it's just something. And then this callback and this. So that should be all we need for that. It still compiles. We're going to quit there. Whoops. We're going to quit there and not worry about how I pasted some stuff in. Whoops. Now, if I search for begin, sending is there. This one is in send callback in us. So here we would actually just say client.begin sending, I would imagine, because all those things are going to be the same. And again, I did it again, didn't I? Were there comments there? No, there weren't. Okay, so go ahead and put that back. And get rid of that and get rid of that because I don't like that sort of thing as a style choice. It makes me sad. And maybe this looks a little tighter now than previously it did. So that's good. So here's what we're going to do. We're going to save this as, new view into file. Then save as this as build client, like so. Now I use git gutter. You'll notice that even though this file is essentially untracked, it still has that because it reused the buffer. So we need to do that to get it to notice. Whoops. Oh, did it not? Did it not do the correct thing? Or maybe I closed the wrong one. There's that one, and build client. So build client is completely new, right? And if that's the case, in build client, throw away everything there, like so. And all we need is this class, which is in dire need of some cleanup, so it's not quite so ugly. And over here, not in protocol messages, in main, it should go in this order. The build client class can completely go away. And still, when I build, that seems to work. And as a test, if I talk to it, this is another test. Not meowf, EOF, and it still seems to do what we want. Now I might actually, again, do that and save as extensions.cs. Oh, I see. It's doing a dumb thing with renaming. Okay, that's nice. That's not how that used to work. But it would explain some things. Now, for the purposes of this one, I'm going to comment all that out. For the purposes of this one, whoops, I'm going to comment all that out. And I'm going to come to main and comment all that out. Now we do need the asynchronous socket listener, but we don't need the extensions. And what happens when we build? Let's just clean this up because I want to clean up these using statements and all of these, and I'm not sure which ones are needed at any given point. So build client, async result. Am I missing one? Probably in build client. So this is the one that it's building first. I'm going to assume we probably want system and system. Does that do anything? Build client, the namespace socket could not be found. So yeah, we definitely want those. And I guess we still need text because we're doing some decoding stuff. For now, that can be gone away with later. That fixes that. So we don't have any conversion code here, and we don't have, excuse me, while I scratch my ear. Maybe I'll also take a sip of the old coffee to see if I can get some wakefulness going here, because I feel kind of sluggish right now. Chugging coffee late at night. Choice of champions. Are we doing anything threading related in this? No, I assume the only thing that needs that is main, so that's okay. And we're not doing any conversion, so that should be okay. Now here, because we don't really need anything in here. I'm kind of surprised that we don't need something there. In main, we're missing async results. So that's, again, let's assume those things are definitely needed. I think we're still going to need threading because, yeah, we need it for the manual reset event. This isn't doing any text encoding now. String builder comes from text, perhaps. So maybe we do still need that one. Okay. Extensions needs. Well, we'll leave it system and we'll leave it system text. And I'm going to get rid of those ones. We actually want to throw conversion code in here too. That might also be a nice thing to make our lives easier in just a second, but we'll leave that. I'm going to leave that commented out for right now. And here in main, I'll still leave it commented out. So if I do a complete clean and then do a build and then run it, I can still do this and say some text, and that works. So bully, and what do we want to do here? Let's say we track the file extensions like so, and stage that, and up here, the only hunk we stage is the one that deletes that class. So what we have staged is that class that's now in its own file and it's no longer there, and then say shift the extension code into its own class file. This makes the top level code a little nicer to look at. And we may have more extension methods coming in the near future. And now, this is one that probably could have been set up as a nicer thing, but we'll stage that whole file, and all the rest of this can be staged, and we will do the same thing here. We'll stage this file and say shift the build client class to its own file. For clarity of code, this moves the build client code out of the main test bed code and into its own implementation file. Along the way, not done as separate commits because we weren't sure what we could get away with. The network code is also fully abstracted out of the main code and into the client code. Clarity. Thus. And that leaves this looking, I think, fairly nice, because as an accept callback, okay, now we can actually change this comment a little bit. Create, okay, we could say create a new client object to wrap this new client socket and tell it to start reading now. And we might cut that code out and come over to here where we have the, whoops, begin reading, and put it there like so. So there's some documentation on how that's supposed to work. So that code is a lot nicer looking. We'll actually amend that commit because that should have been a part of that. We don't actually need to save this, do we? So maybe we can actually do something like new build client handler.begin reading. Maybe that, doesn't need to actually be stashed in a variable. Presumably, as long as that client still exists, because reading is happening for it, it can't be garbage collected away. So that makes that part a little nicer. Now this part is still all grody, but we're going to try and fix that a little bit, perhaps. So this is actually quite tight now. Extensions, okay, we're going to leave that now here. Let's just comment this up a bit. This is, whoops. Create a new client object It's set up to talk over the provided socket connection. Now we're going to make sure that still builds. We're going to do that that annoying thing where here we inlined that, so we're going to stage that, and here we added a comment and did that. We're going to stage that, and we're going to amend that previous commit. Okay. Start an asynchronous send operation for this client. This assumes this works in the same way as the read code, and the code here assumes that our internal state for what we're sending and how much has been transmitted is set up correctly before this is called. Okay, now we also have read callback. Do we actually need this send in this case? Realistically, no. We're passing it the content, right? So theoretically, we could actually make our lives a little nicer. For now, we can and will tweak this later. We can say the client send buffer is for content and the byte sent is none, and then we can say client.begin sending. Instead of doing that, and without having this method at all, just to make things look a little nicer. I would also like to do this. I don't know if that's good style or not. And we're still compiling okay. So we're going to comment this for launches an asynchronous receive operation for this client, pulling as much data as is possible into the client's receive buffer, starting at start location in the buffer. Starting at the start of the buffer. And we'll do that. And maybe if we're going to do that, okay, well, we'll leave that there. Launches an asynchronous send operation for this client, attempting to send as much data as possible from the internal send buffer to the other end, starting with the first unsent byte. And we might also throw a remark on that says this requires that the send buffer and the number of bytes sent be previously set up by external code. Now this is something that we could of course change later. Handle receive event, that's pretty straightforward, especially now that we're doing that. And this one's pretty straightforward. So build, as a matter of fact, for clarity's sake, we're going to clean, then we're going to build. And then we're going to, oh, I'm not going to do that, I'll tell you that. We're going to do that and a little of this and say, that still seems to work. So we're going to stage that file. Oops. I don't know what I clicked, but we're going to stage that file. And we're going to amend the previous commit. Now, I just want to do a little bit more in here. Maybe we'll leave all of that alone for now because it's a little more invasive. Things are more public than they need to be, but a lot of things about this code are more what they are than what they need to be. So let's say that that is no, never mind. Now the other thing I don't know is, do I have to create a new one of these every time? Or could this object just create one? For the time being, we're just going to leave that as is and be curious about why GitGutter seems to think some lines in this file are untracked and others are not. Is it throwing errors in the console or something? Oh, better quit that. That's a rather intriguing question. Incidentally, this is like day 2 or whatever at using Vivala code at 12.25 point. I'm kind of liking it now that I have had a night to get away from the monitor. One night, which was the night before last night, if I remember correctly. When I look at the screen, that doesn't look obviously different than what I'm used to. It just sort of looks like what I do expect, only it has some ligatures in it. So maybe that is cool. I'm going to close build client and then I'm going to reopen build client. And we're going to see that it is in fact all like good code now. The other thing that I would have liked to do, and actually I'm not entirely sure how I would do it. This code that we use for encoding, where we say buffer block copy and message factory converter get bytes, that really seems like something that it would be nicer to clean up, but maybe we don't worry about that for the time being. So the first thing that we want to do, let's say, is read one or more binary messages and decode them. I managed to blow a fair amount of time just making this code a little easier to read. That tends, in my opinion, to pay dividends. You understand your code better and it's easier to work with, which makes you faster in the general case. I'm probably going to be sad that I am now officially out of coffee. Okay, so we have this nicely segregated so that we have a read buffer. And I'm going to actually make this maybe, well, we don't need to make that bigger per se. But what do we need to do here? I think now this file here is also an example of something that should be cleaned up. It has the factory, it has all of the classes all just in here, which is kind of irritating. But if we think about this logically, how do we receive data for a message? We need to read first 4 bytes off of the line, exactly 4, convert them from a big endian number into a local endian number. The thought occurs that the translations between big endian and not are actually, and I'm surprised this did not hit me sooner. We can't use our, I have to say this now just so I can keep it straight in my head. We remember when we were looking at this, we made a little endian converter and a big endian converter, and also we just used the internal bit converter class. And what we learned is internally bit converter converts everything to little endian because that is what architecture this system is right now. There's no way to tell it that you're giving it big endian data and to convert it two little endians. So we're using the miscutils class by John Skeet to provide us the big endian and little endian encoder. And we're actually using a big endian encoder in protocol messages and a big endian bit converter, I should say, to convert numbers to and from big endian format into the local format. The thought occurs that if we were actually on a big endian system when we did this, then you don't need to convert squat. And I haven't looked at that code. I don't know if it's smart enough to just know that if the endian is big endian, then don't do anything. Just pass it through. But if it's little endian on the local machine, then do so. I would assume that that is in fact what it's doing, but that is a sort of a call ahead item. For all the machines I have to test with, that's not going to be an issue. But in any case, how do we receive messages? We need to receive 4 bytes off of the line. We need to interpret them as a 4-byte integer. And then once we know that, then we need to actually get that many bytes of data. So I'm thinking, this is my thought process here, that, and we'll just implement, well, maybe we don't even want to, let's save as protocol message as partial message, let's say. And if that's the case, we need to close that file and reopen it so Gutter knows what it's doing. We don't care about that. We don't care about that. I don't really care about that. We really technically don't care about anything, but public class partial message is what we have here. And we're going to create an instance like so. And what API do we want to have on this? This is going to wrap all of the stuff. Actually, I guess we don't want to encode it. I'm going to reopen protocol message. Actually, let's copy that and then revert all of the changes back to how we started so that we can actually look at this again. Now that's the class that we're making. I don't think we care about that per se. And message factory has a from data that returns a protocol message. So maybe we might say public I protocol message get message, which returns something. Well, we might actually say that it returns message factory dot from data some data that we don't know what it is yet. And we might have a public int needed needed bytes and a public this one you're going to create a partial message, and then you're going to ask it how many bytes do you need. You're going to have to give it bytes somehow, and you're going to say public bool is complete to know if this message is complete or not. So it's going to say return false by default. Now the thing is, how do we get bytes into this thing? We might say from a byte buffer at a given offset. So let's private byte message data. We want a uint32 payload length. Well, I guess we just call it message length, wouldn't we? Message data is equal to null and message length is equal to 0. Is it considered good style to statically initialize things, or it's not statically, but to initialize things that way instead of doing it in the constructor? Because that just seems weird. This is going to be the message data that we have. This is going to be the actual length of maybe we don't actually need that. We'll see. We're going to work this out here. We need a private, we'll just call it int, I guess. Whoops. No, maybe that needs to be a, we'll call it an int. This code needs to be tweaked later anyway. We're going to say this is bytes read or bytes used. Let's say. So let's use these to try and see. We'll define that to be 0 as well. How many bytes do we need? If oh my goodness, it's not going to be quite right. We're going to say, first of all, this. If message length is greater than 0 and bytes used is equal to, no, maybe I need to do that. Dang, I just realized that the coolness of this. I think all of these bits don't need to be here anymore, but we can find them easily enough if we do, because we can look in the other file. Now, does this all still? Oh, that's an unhappy state of affairs at line 18. Oh, because that's not actually valid code. Yeah, okay, that makes sense. Line 33, I forgot something important. It's not a bad file descriptor. It's working. Not all code paths return a value. Okay. So I guess if this returned 0 and this returned 0, then it would probably be happy. Yeah, warnings are okay. So here's the idea of how this is going to work overall. The build client is going to call begin receive as it normally does. And then in the read callback, if it doesn't have a partial message, then it's going to make a partial message. And in that case, it's going to create the message, and then it's going to ask it, how many bytes do you need to complete things? Maybe we don't even need to do that. Maybe we can just give it bytes. That might actually be the better way to go there. And let's say private byte message len bytes is equal to new byte 4, let's say. So just warnings. So this is always going to be allocated for a message. It's the 4 bytes that we need to know about the length. So we can say the bytes that we are reading so that we can determine how big the message payload is. The array is allocated at init time and decoded as a binary, as a big endian value once all 4 of them are consumed. Now, the bytes that make up the actual data. We're going to know that message length of 0 is not valid because the minimum message length has to be at least 2 bytes because it has to have the 2 bytes in it that tells you what kind of message it is. So a message length of 0 is going to indicate that we don't know the length yet because there are still bytes in here that need to be used. And here, the bytes that make up the actual data in this message, this is null when we don't know how many bytes we need, and an allocated array once we have determined the length. And in either the message len bytes or message data arrays, this tracks how many bytes of the bytes provided, of the bytes that can be stored in the array have been stored in the array. So here's the first thing we want to say. How do we know if our message is complete? We know our message is complete if message length is greater than 0 because it starts at 0, and until we get 4 bytes and decode it, we don't know what the size is. So it has to be greater than 0 for this to be complete. And also, bytes used has to be equal to message length. So we can actually maybe just return that. So the idea is if the message length is 0, we haven't read 4 bytes yet, so this is not complete. If the message length is greater than 0, then bytes used is telling us how many bytes of data we've actually consumed thus far, and the message isn't complete until we've got as many bytes as there are there. Now that's just an empty constructor, so maybe we'll join that up to keep that nicely and say constructor empty. And here we might say give some bytes from the provided data at the given offset to this message. The returned value is the number of bytes that have been consumed from the data array, which may be 0 or may be the entire contents of the data array that still remain at the given offset. And that's the thing. And here, if is complete equals false, then throw new something. Invalid argument exception? Yeah. I don't know. What a good exception here. C# exception for missing data. Hey, how about that? Invalid operation exception may be suitable. This exception is thrown when you call a method on an object, but the object state is not appropriate for the operation. Okay. Throw no invalid operation exception. Jump back over to here. Invalid operation exception. Message is not complete yet. Otherwise, do that. So we are sort of building here and being, oh, I forgot another one at line 40. Right there. I don't know if that actually, oh yeah. Sometimes that little build error stops the output from appearing. Operator equals equals cannot be applied to operands of type method, group, and bool. What the hell? Oh, whoops. Okay, there we go. There we go. Partial message data is assigned, but its value is never used. Good, good. So here's what we're going to do. We're going to say give bytes. We're going to say if message length is equal to 0, then what do we do in this case? We know we need to put bytes into message len bytes. I'm actually going to have to skip over to this thing in order to find an appropriate this. Int remain is equal to data.length minus offset. So this is the number of bytes remaining in this operation, right? The entire array that you're passed in has some length, say 10. If the offset is 0, there are 10 bytes remaining. If the offset is 1, there are 9 bytes remaining. If the offset is 9, and 10 minus 9 is 1, there's 1 byte remaining. That's sort of unfortunate. Data length is 10, offset is 0. 10 minus 0 is 10. 10 minus 1 is 9. Well, I think that actually sort of works out in our favor, so we're going to leave that alone. C#, min of 2 value. Oh. I assume there's a math.min. Okay. One would have assumed that was the case, but you never know where it might actually be stashed. The first I'm just going to assume. So here's what we're going to say here. Let's comment this up. If message length is 0, we don't have all of the bytes needed in message len bytes to know how long the message is. So try to grab that many. And we're going to block coffee. The source is data, and the offset is offset. And the destination is message len bytes. And the offset is bytes used. And the number, does this return the number of bytes copied? That would be very handy. Public static void. Copy the specified number of bytes from the source starting at a particular offset to a destination array starting at a particular offset. So we're going to say var taken is equal to the math dot minimum of the remaining bytes in the buffer or the message len bytes dot length minus bytes used. How many bytes are we going to take? We're either going to take the number of bytes that are remaining in this array, or we're going to take the number that gets us up to 4. So when message len bytes or message bytes length is always 4. When no bytes have been used, it's 4. When 3 bytes have been used, it's 2. When 4 bytes have been used, it's 0. That's never going to be the case because we would know that. So the best this is going to be is 3. Then it's going to be the length of the bytes minus 3, which is 1. And 1 is maybe 1 is lower than the remaining. Otherwise, it's not, but who knows. And the value here will be taken. Now, I think that should shut up the last of the warnings because all of the values are used. Okay. Figure out how many bytes we want, which is either the number of bytes needed to fill out our message len bytes array or the amount of remaining data, whichever is smaller. Copy the number of bytes we are taking out of the data array at the given offset, then update the offset and the number of remaining bytes. So what are we doing here? We're saying offset, is equal to the number of bytes taken. We need to say bytes used is increased by the number of bytes taken. The offset in the buffer that the data that we were given is increased by the number of bytes taken. So that's update the offset and the number of remaining bytes. So we might also say remain minus equals taken. So the remaining value is updated as accordingly. And now we can say if bytes used is equal to message len bytes length, then in that particular case we say message length is equal to something. We might actually want to do that. And we want to say bytes used is equal to 0 again. Okay, so what's the something that we need here? It is something on the order of not get bytes. This one. Message length. The opposite of get bytes, so it's a uint 32. Oh, I guess we might need to look here to see what we did. You're giving it this one. So we need the big endian converter to uint 32. So how are we doing that here? This one. And And that is the something. Message factory convert to uint32 message len bytes and starting at offset 0. And it knows that it needs 4 of them. Now we have that. We need to return the number of bytes that have been consumed. So we might want to say int taken is equal to 0 up here. And here we can say taken is equal to the minimum of those things. So if message length is equal to 0, do that. This might cause message length to not be 0. So if this is the case, do that, else return, like so. So what we're going to say is, if the bytes used is the entire length of the message bytes length array, then we have all of the bytes we need. So decode, and we have to return taken here, otherwise something will go wrong. Decode and get the message length ready. If that's not the case, we don't have enough bytes yet, so just return back. That means we only get to this point right here. Tried to consume bytes from the message. Now this is the unfortunateness of, we could actually just return the number of bytes taken one way or the other and have the other end call us again, but this seems nicer. If we get to this point, and we are actually at over an hour in this thing, so I got about another 20 minutes in me here, and then we're going to have to call it quits. But hopefully we can get binary message decoding done in that time. This is the trickier part of this operation. We only get to this part when the message length wasn't 0 when it came in, or when it was 0 when it came in, but we filled out the entire buffer. So what we need now is taken is equal to, oh, see, the problem is we need to update that buffer, but we need to know how many we took. Which is one of those unfortunate type things. Maybe this could be abstracted away into another method. So we know how many bytes we need and how many bytes we've actually used. Now, as a matter of fact, message data needs to be updated here as well. So we might not need message length here at all, but we might want to say message data is equal to new bytes message length, like so. So that kind of does what we want. Ooh, it does not exist in the current context, huh? Probably should have paid more attention to that. Line 63. Did it compile before I did that? The name message, oh, there's no G in it. Okay. Phew. That's going to look like that. Bytes could not be found on line 65. How did I, oh, whoops. New bytes. Good gravy. It's new byte. That's why it's a problem. Here. Again, Python on the brain. Okay, how about that? Now, if that works, let's say we don't actually need this value. The bytes we're reading so we can determine how big the message payload is. The array is allocated at a init time and decoded as a beginning value once all four of them are consumed. So say we don't need message length there at all. Then here we get this to say if message data is equal to null. We don't have all the bytes needed in message length bytes to know how long the message is, so try to grab that many. So in that case, we figure out how many bytes we want, which is the number of bytes we need to fill out the array, or the number of remaining, whichever is smaller. We block copy. We do that, and if bytes used is equal to that, then we can say var message length is equal to that. Bytes used is 0. Oh, let's put this one first. So if the number of bytes we got is the number of bytes in that, which we know is 4, but we don't want to hard code that number, then convert those 4 bytes starting at position 0 to this variable, allocate message data to be an array that big, and say bytes used equals 0. Otherwise, there wasn't enough, so just return the number of bytes that were taken. Now, this, instead of being this, needs to be message data is not equal to null, and bytes used is equal to message data dot length, which I think should cover all of the cases. That's just going to tighten that up a little bit. We know how many bytes we need and how many bytes we've actually used so far. So we might say var message bytes needed is the math.min. Now I actually use that there. I guess that's just something that's always there. The minimum of what? The remain value, the number of bytes that are remaining, or the number of bytes we need, which is message data dot length minus bytes used. That's how many bytes we're going to need for this operation to complete. And then in that case, we can also say what we did up there, buffer. Okay. Copy that number, copy the, try to consume the bytes of message. We know how many bytes we need. Determine how many, why is that, oh, because this isn't, should be one of those. Determine how many bytes we can actually grab, which may be all we need or only a smaller set. Copy the data over and update our values. So here we would say buffer copy, buffer dot block copy from data at offset, which we updated above if we needed to, into message data at position bytes used of length message, well, what change that to message bytes taken. Like so, and once we do that, we need to say bytes used plus equals message bytes taken, obviously. We don't need to worry about the offset, and we don't need to worry about the remaining, but we do need to say taken is equal to plus equals to message bytes taken, so that if we used some from here and from here, they both combine together, like so. And then we return, well, actually, we can just return taken plus message bytes taken. We don't even need to combine that. I think that might be all we need. So here's what we're assuming. Message data is the byte array. It's either null when we don't know how long it's supposed to be, or an array allocated for exactly the appropriate length when we do know what it's supposed to be. This is a 4-byte thing because that's the size of a uint2 that is always allocated no matter what. But until this is allocated, we know we haven't used the value here, and this is the number of bytes we've used in either of those two things. So you're going to call this and say, here's some bytes, here's a buffer, here's an offset in the buffer, and this is going to try to take as many bytes as possible out to pull one particular message. And if it gets a whole message, good. If not, it updates its state accordingly, and it returns the number of bytes that were taken out of the buffer so that the other side can keep calling it and getting messages until it finds out that it can't get any more messages. Now, how do we pull this off? The first part is this. If message data is null, which is the actual data of the message, then we know we haven't received the 4 bytes we need yet to decode the length. So we figure out how many do we need, which is the number of bytes that are in that array minus the number of bytes we've used, which starts off at 4 and then goes to 3 to 2 to 1, but it's never going to be 0 because the other logic will have triggered, or the number of bytes that are currently remaining in the buffer based on its size and what offset we were provided. Then we can copy those bytes out. Now, if we actually copied enough bytes, however many we took, whether it be 1, 2, or 3, if we took out enough to fill the entire message bytes array, then we can turn it into a message length, allocate our data, and reset buffer bytes used to be 0 so we can continue through. But if that's not the case, then we started off not having 4 bytes and we ended not having 4 bytes, which as we saw could happen if the sends were happening 1 byte at a time, in which case it just immediately returns with the number of bytes it took. So we only get down to this part if we had enough bytes to fulfill this header and there was some left, or we already had a header when we called. And here we do the same thing. The minimum the bytes we want is the minimum of the number of bytes remaining and the number of bytes we need, so that we make sure we never take more than there actually are. We block copy from the data at the offset provided into our message data at the bytes used for the number of bytes taken, update the number of bytes used so we know, and return the appropriate value. Now, at any point, you can say, is this partial message complete? And how do we know if a partial message is complete? When the message data is not null, because if the message data is null, we haven't read those first 4 bytes, so we don't know that the message is done. It can't be done because we don't even know how long it is yet. And assuming message data is not null, it's only complete when the number of bytes we've used is the size of the array that we allocated, which means we knew the message was 12 bytes and we've actually put 12 bytes into it. Wow, that's the tiniest sidebar I've ever seen. I don't normally use the sidebar. And then when you call you can call get message, and if the message isn't complete, it throws an invalid operation. Otherwise, it uses the message factory to decode it and return it. So given some bytes, we do that, and then we say this is determine if this partial message is complete or not. A message that is complete can be decoded, while a message that's not needs to have give bytes called at least one more time. Okay, and we'll go ahead and wrap that. And convert the internal message data into a decoded message. This will throw an exception if the message is not yet complete. So let's go ahead and do that. Now let's just double check what happens if this message is completely filled out and you called give bytes anyway. It can still figure out how many bytes are in the buffer. It knows we took none. Message data is not null because we know the length of the data, so we skip that. Now we come to here and say the number of bytes taken is the minimum of the number of bytes remaining and the number of bytes we need. If the number of bytes is 0, then it's going to block copy 0 bytes. Then it's going to say the number of bytes used goes up by 0, and then it's going to return 0 plus 0, which is 0. So if you call this and it returns 0, that's also a good indication that it's done. So that compiles, and that is cool. So here we're going to come up here and say, we'll make it public because everything is public. Partial message in message is equal to null. Okay, so which is the data for the message that we are currently reading. This is null when we have finished with a particular message. Now this class could be smart enough to reuse, but that is okay. Maybe we don't even want that to be null. We're definitely just going to always be reading messages, right? So if we just throw it away, we allocate one if there isn't one. New partial message. Okay, so let's do that. Now, I'm going to unzoom that and send that over there. So that we can see it. And we are not begin receive, but read callback. Okay, so here's the part where we actually smarten this up a little bit. There is a read buffer size and a read buffer. I don't know why that's necessarily the case if you could just ask this, so that might be something to pajigger around later, but let's say we don't have this anymore. That's going to bust some stuff, and we can find all those locations, and that's where we know we're going to do something here. Whoops. That's this one. Okay, now maybe just size this down because I need to remember how to call that, but I don't need a bunch of information. So we read data. We don't care about that. We got the client. We received. If it's 0, it's closed connection. Say we read bytes. Now here's the thing. We don't need to do that. Actually, we could actually be maybe fairly smart about this, but okay, let's just, for the time being, okay, let's see. We're gonna comment all of it out, including that, even though we actually need this. Okay, so we could then say, end by getting ready to read more data, like so. So that's going to mean that when we are in our little thing here, when we run it and talk to it from a terminal, which is still okay, I could say some bytes, some more bytes, even more bytes. It just keeps reading, but nothing ever happens with the data, which is Great. So let's stop that from running and come back to here. Now, we're going to want to read this stuff in a loop. I'm going to guess, since we read into the buffer, bytes read is the number of bytes that we actually pulled. So I'm going to say var, well, let's say int bytes used is equal to 0. And then we can say while bytes used is not equal to bytes read, do the stuff in here. And we're going to start by saying, what did we name our thing? In message. We can say if in message dot is complete, then we can say var message is in message dot, that thing I can't remember what it was, in message dot get message. The thought occurs that I'm not making C# nice code because I find it incredibly irritating to have method names be all uppercase all of the time. They're proper name cased as opposed to this style here. And we're going to throw a that in and a message, and then we're going to say in message equals new partial message so we can go again. So while then we reread some number of bytes that's not 0, the number of bytes we used is none, while the number of bytes used is not the number of bytes read, then we can say if the message that's partial complete, if so, use it and make a new one. We don't even need to do that part there. We can say bytes used is equal to in message dot give bytes, and the bytes we're going to give are from our little socket buffer here, which is named what? Client.read buffer. And the offset to provide is bytes used. So give some bytes to the current partial message so it can reconstruct itself. Thus, okay? And then bytes used is equal to that, and we've incremented the number. If the message is now complete, then we print what it is just on the screen. We're not going to echo it back yet. Create a new partial message to start fresh and go back to the top. And now if it has used up all of the bytes, it stops and reads more data, but otherwise it continues. Non-invocable member in message. So what have I done wrong here? Oh, this should not be as many of those as there are. Is that happy now? Well, I'll build it again. I'm okay with that. Int message doesn't exist. Yeah, well, I'm not surprised. I typo a lot. We'll go like so. And again, I'll rebuild it because there are some issues. The console is filling up with bad file descriptor on this because it's trying to read from a file that doesn't exist any longer. Some weird issue. All of that code can maybe go away. We're going to leave it there for the time being until we finish the echo part. But I think if that is the case, what we need to do is cd into local source Devember 2018. And, well, actually, I'll look at it here, shall I? network.py. So what are we actually doing with our little code here? Not that, because we're in the wrong nt network.py. Excuse me, I'm in the wrong one. Okay, so let's scoot right on down to here. We make a connection manager, we start up. Now let's say we're actually connecting not to localhost, but to Dart on port 50,000. And then we're going to send an introduction message, and this is an arbitrary message, go us. We're going to wait a little while to see if we get messages back, which we're not gonna. And then we're going to shut things down. So the first thing we're going to do is jump in here and .NET run this beast. Thus, and then I'm going to go into the terminal and actually cd into net test and Python 3 network.py, and let's see what happens. This is exciting. Oh, wow, that is some kind of unhappy right there. It doesn't know that it's disconnected, so that's unfortunate. Object reference not set to instance of an object in from data at partial message. Read callback, partial message, get message in. Did I not implement that correctly? Oh, yeah. Stoopnagel. Message data, that bad boy. Message data the heck out of it. Rebuild. Okay. That was impressively stupid. And, oh yeah, I guess this doesn't necessarily know that the connection is closed because it's not trying to do anything. That may or may not be an issue. I mean, I think in the general case, it would probably might have noticed, but that's neither here nor there. That's something to worry about later. So let's try one more time. Let's .NET run that. It seems to be running, and then we will run this again. And we read 63 bytes, and we got an introduction message for version 1 and an error code that says 77341926 message. This is an arbitrary message. Go us. And then the client closed the connection. That is fantastic. Now, I want to go here because we have a line here where if we do that, then this will actually send 1 byte at a time instead of all of the data all at once. And let's see how well that works for us. Hopefully we can send all of the data before everything finishes. So reset that, and okay, now that's blowing up. What did we do wrong here? Message data length is invalid. Partial message, get message. What actually happened there? We read 1 byte and then it immediately went into the wrong thing. So we are at an hour and a half here, and I'm probably going to be quite unhappy, but it's going to bother me if I don't get this going. So let's take a look at partial message and maybe add some logging here. So we might say CW no message data yet, and then we might say we want to take 0 bytes and taken. Then it copies, and here we might say, I think we have all of our bytes now. And we'll just see what that does for us. Okay, that's good. That's I don't know if you can do this in here. Yeah. I think I've tried that before and discovered how unhappy it makes things. We'll just go ahead and quit that and come back and say .NET run. Oh, sorry. In remote build server dot. So that's running over there. And if I run this here, okay, I say no message data yet. We want to take 4 bytes. I think we have all of our bytes now. So we got 4. Why does it say message data length is invalid? Is that something that we actually wrote? Oh, I turned that off because some guy was asking a question. We are in partial messages and we look for length is invalid. No, sorry, we are looking at protocol messages. If data.length is less than 10 for an error message, well, I think the real issue there might be that it tried to do something that it didn't need to. Now we're gonna, I guess we'll do the same thing here. CW, we want to take bytes for the body, message bytes taken. And total bytes taken this run is that. You know, the more you try to hurry, the sadder you get. Taken plus message bytes taken, like so. Not null and bytes used is equal to message data dot length. Bytes used was set to 0. Let's also say is complete 0, 1, and we want message data and bytes used and message data dot length. I assume this uses short circuit evaluation. Okay, so let's go back here and run it again, and we'll give her one more try. Now, what did we see here? Total bytes taken this run 4. So we did not and we might say message data dot length here. Now, did I make this accidentally? I wouldn't have thought so. I'm sure there's something stupid that I'm doing here. One more try, he said, being sadder all the time. Is complete. Okay, this is the stuff. Whoa, oh, there's quite a few of these. Okay, so maybe that was less of a problem. Let's have a lot of empty space and run it and try it, and then we'll know for sure exactly what the deal is here, because that can be confusing sometimes. So new incoming connection, we read 17 bytes, no message data yet. We want to take 4 bytes. I think we have all of our bytes now. Message data is 3 bytes. We want to take 3 bytes for the body. The total bytes taken this run is 7, is complete. It's an array. 3 is 3, is complete. 3 and 3. I don't know why that's doing that twice, but we read a message introduction, then no message data yet. We want to take 4 bytes. I think we have all of our bytes now. The message data is 52. We want 52 bytes for the body. Total bytes this run 56. 52 is 52. We get that. We say no message data yet. We want 4 bytes. I think we have all our bytes now. Message data is 0 bytes. But we only sent 2 messages, right? So maybe that is not entirely the fault of this and there's something else going horribly awry. Again, that is not the correct version of this file, is it? No, oh, it is. There we go. We're sending only those 2 messages. Why did it think there was more message data? So maybe we'll just quickly jump over into here. It says how many bytes we were read, so we can say CW bytes used so far is that, and we'll throw in a bytes used right there. Did we accidentally go past bytes read and it's going too far? It should actually be smart enough to not do that anyway, but in any case, again, we'll do that and jump to the terminal. And let's see. Okay. New incoming connection. We read 17 bytes. No bytes. Bytes used so far 0. We took up 4 and we took up 3. Now the total run is 7, which is correct. And then we read the message that, which is 4 and 3, which is good. And bytes used so far is 7, which is the one that we just added right here. No message data yet. We want to take 4 bytes. I think we have all the bytes. Message data is 52. We want 52 for the body. Total bytes taken this run is 56. 52 is 52 and 52 is 52. Then we get that. Total bytes used so far is 63. The number of bytes we read was 17. What? So how if read callback says, and we'll actually do this, read 0 bytes, or read that many bytes, how exactly is it doing that? So let's fire that up one more time. I really do have to drop out of here because this is going quite long already. I did not intend to go this long. This only happens when it's reading single bytes, which proves our code is somewhat bust. So the only thing that it says we read was 17 bytes. And if that's the case, how did it successfully pull this message out? Because it only thought it read a little bit of data. Oh, maybe I need to. I'm gonna do this too. I don't think we're gonna see this, but we're gonna have to check this code in, even though it's broken, which is an unfortunate state of affairs. But what can we do, right? What can we do? I suppose I actually need to run the thing. for that to have any sort of effect. Let's do that. And here we go. Red. I really don't understand how it's possible for this to happen if we only read a certain number of bytes. How is it just going forever and ever and ever? Tapping my fingers on the desk, wondering why, oh, why. Now, if I actually went back to the send code and swapped those two lines back so that it sent all of the data in one shot, then what do we see when we do it? We see it say it read 63 bytes, and it does what we expect. Now, here's the thing that confuses me about this. It actually says it's out of the loop because the number of bytes it used is the same as the top, and the client closed the connection on us, but it also says this full message that was transmitted from the other side. So, whoops, I did that wrong. If I did that, again, we throw some extra blank lines in here. This is still the same run, and we go like so. We get it to blow up. And we get it to blow up because it thinks it read 5 bytes, but it gets an introduction message with version 0. So it decided it was done before it actually was done. And then when it gets to that part, it's bust. So, okay, that at least makes some modicum of sense. There is a problem in our partial message code. Figure out how many bytes we want, which is either the number of bytes needed to fill out the thing or. Do we not set bytes used to 0? That's null. That's an array. So let's just double check. What did we see when we did that? We saw that it read 5 bytes. The bytes so far. Now 5 bytes should actually be enough. It should be, I guess it should be. It should be 4. There's no message data. We want to take 4 bytes. They grabbed 4 bytes. The message data is 3. They want to take 3 bytes for the body, but how many did they actually take for the body? I think maybe that is the issue. The minimum of the remaining bytes, and which is the length of the data array minus the offset that was provided, which I think is correct. And the remaining bytes is taken off by that. We don't modify, no, we modify the remaining bytes there. And if the bytes used are equal to the message bytes length, then we have all of the bytes. We convert it, we create our new array, we know how big it is, we say bytes used is 0, and we continue down. The minimum of the remaining and that. So let's throw a couple of these in here and we'll just see. Whoops, remaining in buffer that, whoops, remain. Notice how much quicker this went for the Python code. This really will be our last run unless this is very obvious what it's doing wrong, because I am quite tired and I got to get my blog out and it takes a ways to do. So we're going to do that, and we're going to do like so, and let's just take a look and see. It got a new connection. It read 17 bytes. The bytes used so far are 0. That means the remaining bytes in the buffer are 1024. Oh, I see. It's not the length of the buffer. We need to know how many bytes there are. Okay, thank God. That actually makes hella sense. From the read buffer of size bytes read, bytes used. Okay, and then we go over here. Thank the heavens. Int buffer len, like so. Now, instead of everywhere we see data.length, we're going to put, oh, sorry, we're going to put this everywhere we see this. That was a rather dumb mistake. There's only one of those, huh? Okay, so that. Oh, good the heavens. No, don't display all 5,000 possibilities. Let's do that and run that and run this. And look at that. It seems to have done what we would have wanted. So I'm going to come back over here now. I said that was going to be our last run, but we want to see, well, quit it, what it looks like when we don't have a bunch of crunk in here, like so. And that one, and that one, and that one, and that one. And we want to keep that, and we want to keep that, and we want to keep that. So let's say, well, we get rid of that one, and build. And it's sort of, I guess, a fluke that it worked the first time in this particular case, but we run that there, and then we come over here and run this. Read 14 bytes. Oh yeah, we need to remove the stuff from is complete, but it has done what we wanted. Let's go ahead and move that as well. Oh, sad for me that that was a little, okay, like so. And quit it and run it, and over here and run it, and we see that we got a message. We used 7 so far. We read 46. Bytes used so far is that. The client closed the connection. It all works. We don't want this one in there. And that is the end of the stream at a gobsmacking almost 2 hours. This is the sort of thing that I'm going to be so sad about tomorrow when I am so tired, but it is very fulfilling to have a problem and solve it and feel extra dumb because I know that an array's length bytes don't specify the length of the entire array. That's why I had this bytes used in here so that I could track how many I actually put in there. Duh. Nevertheless, that's going to be the end of the stream. Thank you for watching. I hope you had fun watching me be a doofus and ultimately succeeding. And that is going to be the end of this Devember 9th show. Continuing on tomorrow, we're going to be working on sending the binary messages back, and then we're good to go. We shouldn't have wasted time making the code easier to read, I guess. But standard rules apply. I'm going to go drop off this live stream, create the blog, then commit the code while it's rendering and uploading, get myself to bed, be very, very tired in the morning, but fulfilled. And for this evening, thank you very much for watching. Don't forget to like the video if you liked the video, and subscribe to this channel or my other channel. Links to both in the descriptions below if you want to see more of these. And for now, have a sublime day, everybody. Have a sublime Devember day.